In the absolute deep freeze just beyond the orbit of Jupiter, the temperature hovers near -240 degrees Fahrenheit. Out there, in the dark, water is not a liquid. It is a mineral. It is as hard as structural steel. The laws of basic thermodynamics dictate that an isolated mass of ice and rock tumbling through this freezing void should be entirely inert. It should be a dead, silent tomb. It does not possess the internal heat to change its own structure. It certainly does not possess the energy to spontaneously and violently detonate. And yet, something just broke that rule. For the last several months, the most powerful telescopes on Earth have been tracking a ghost. A highly unusual object, moving at a blistering speed of over 50,000 miles per hour, slicing through our solar system on a hyperbolic trajectory. A path that guarantees it will never, ever return. It is only the third object of its kind we have ever confirmed. A true interstellar traveler. A stray bullet born in an alien star system, wandering the Milky Way galaxy for billions of years before briefly grazing our sun and heading back out into the endless dark. Astronomers named it 3I Atlas. We were simply watching it leave. We were pointing our lenses at its fading light, trying to capture the final scraps of data before it slipped beyond the reach of human technology forever. The scientific narrative was supposed to be a quiet farewell to a frozen, harmless wanderer. But as it crossed the boundary of the outer solar system, far past the warming rays of our star, the object did not freeze. It did not go quiet. Instead, it experienced a massive, completely unexplained surge of energy. Telescopes registered a sudden, blinding spike in brightness. The solid core of the object fractured. It erupted, expelling an enormous cloud of debris into the vacuum, completely altering its own trajectory and accelerating even faster into the void. This was not a standard cometary reaction. This was an explosion of total structural failure. An energetic event happening in a region of space where there is simply zero solar energy to trigger it. Rocks do not just explode in the deep freeze of space for no reason. Something had to light the fuse, something buried deep inside that object, or something unseen that interacted with it in the dark, generated enough violent heat to tear it apart from the inside out. Right now, the global astronomical community is scrambling. Observatories are desperately trying to download and process the final fragments of light captured during the blast. Because the initial telemetry, the raw, unfiltered data coming back from that shattered ghost, simply does not fit our understanding of the physical universe. To understand why the telemetry from this shattered traveler is causing such a quiet panic among astrophysicists, we have to entirely deconstruct our common sense. We have to strip away the warm, comforting intuition we have about how the universe works and look at the brutal, freezing reality of deep space. For the entirety of human history, we have lived our lives huddled around a cosmic campfire. Our sun is a raging nuclear furnace, and we happen to orbit it at the exact right distance to keep our oceans liquid and our atmosphere thick. Everything we understand about heat, energy, and matter is heavily biased by this cozy little bubble of warmth. Because we live so close to the fire, our intuition tells us that heat is a given. If you leave a block of ice outside on a summer day, it melts. If you heat water, it boils. If you pack combustible chemicals into a tight space and apply a spark, they violently expand. Energy is always transferring, moving, and reacting. But the moment you step away from the campfire, the moment you move past the orbit of Mars and out into the vast, dark territories of the giant planets, that intuition becomes completely useless. Space is not just cold. It is actively hostile to the very concept of activity. Think of the outer solar system like a massive, abandoned factory in the dead of winter, with the power permanently cut off. Down here on Earth, our bustling city is full of light and noise. But out there, past Jupiter and Saturn, the environment is defined by an overwhelming, suffocating absence of energy. When astronomers historically looked up at comets, they saw omens of doom, glowing swords hanging in the night sky. But as the centuries passed, the great minds of early astronomy began to map the heavens. They realized these glowing apparitions were not magic. They were just rocks, very dirty, highly primitive snowballs left over from the construction of the solar system 4.5 billion years ago. We learned that comets only put on a show because they are falling toward the fire. As a frozen chunk of ice and rock dives in from the outer dark, it crosses an invisible boundary we call the frost line. Once it gets close enough to the sun, the solar radiation acts like a blowtorch. The vacuum of space means there is no atmospheric pressure, so the ice does not melt into water. Instead, it undergoes a process called sublimation. The ancient ice instantly flashes from a rock-solid solid into a sprawling, chaotic gas. That violent venting of gas and dust is what creates the massive, glowing tail of a comet. It is just a pressure release valve. The heat of the sun cooks the surface, and the comet bleeds material out into the void. It is a natural, predictable, and entirely understood thermal reaction. We have watched thousands of comets do this. We have mapped their orbits. We know exactly how they behave when they get warm. More importantly, we know exactly how they behave when they get cold. The fundamental rule of a comet is that its activity is strictly tied to solar radiation. The physics of light dictate that as you move away from a light source, the energy drops off at a massive, exponential rate. It is not a gentle fade. It is a mathematical cliff. Imagine you are driving down a pitch-black highway in the middle of nowhere with thick fog rolling in. Your headlights illuminate the road 10 feet in front of you clearly. But 100 feet away, the light is practically gone. The energy of the beam is swallowed by the distance and the dark. The sun works exactly the same way. By the time you travel out to the orbit of Jupiter, the sun is no longer a life-giving furnace. It is just a painfully bright star in a black sky. The solar radiation is so weak that it cannot even penetrate the surface dust of a comet. Because of this, astronomers have always operated on a comforting, rock-solid assumption. Once a comet is leaving the solar system, once it crosses back over that freezing frost line, it dies. It goes dormant. The outgassing stops. The tail fades away into the vacuum. The surface temperature plunges back down toward absolute zero, and the object becomes a geologic corpse, falling silently back into the abyss. It is a rule written into the very architecture of celestial mechanics. Things do not wake up in the dark. They go to sleep. And that is exactly what 3I Atlas was doing. This interstellar wanderer had already survived its close encounter with our sun. It had flared up, vented its alien gases, and survived the heat. For the last several months, observatories watched it aggressively accelerating away from us, moving out past the orbit of Mars, crossing the asteroid belt, and plunging deep into the freezing territories near Jupiter. It was following the rules. It was shutting down. The light bouncing off its surface was fading, dimming exactly as the mathematical models predicted. It was becoming a dead, silent rock, moving at 50,000 miles per hour, returning to the interstellar void from which it came. And then, it shattered. It did not just vent a little bit of gas. It did not experience a minor thermal crack. The entire solid structure of the object suffered a catastrophic, explosive rupture. To understand how utterly impossible this is, we have to look closely at the mechanics of an explosion. An explosion is not just a bright flash of light. In physics, an explosion is a rapid, violent release of energy that forces matter to expand outward at extreme velocities. It requires an ignition. It requires a massive amount of kinetic or thermal energy suddenly unleashed. If you take a block of ice and rock, cool it down to -200 degrees, and place it in a vacuum where there is zero external heat, it will sit there for 1 trillion years. The atoms themselves are sluggish. The internal chemistry is completely frozen. It possesses no mechanism to suddenly generate heat. It is like expecting a car engine to spontaneously start and rev to maximum RPM while sitting at the crushing bottom of the Mariana Trench. It simply cannot happen. The energy required to shatter a solid mass of interstellar ice is monumental. So, where did the energy come from? In the immediate aftermath of the event, scientists working with the National Aeronautics and Space Administration and the European Space Agency scrambled to find a conventional answer. They desperately looked for a natural explanation that would preserve our understanding of the universe. The first and most obvious guess was a collision. Perhaps this dead rock, speeding through the dark, blindly slammed into a hidden asteroid. A high-speed impact would generate intense kinetic friction, melting the ice and shattering the object in a split second. It makes logical sense. It is the kind of clean, physical explanation that lets scientists sleep at night. But space is not a crowded highway. Space is defined by its emptiness. The asteroid belt is not a dense field of tumbling boulders like you see in science fiction movies. The distance between objects out there is so unfathomably huge that you could fly a fleet of spaceships blindly through it for years and never hit a single pebble. The mathematical probability of an object moving at 50,000 miles per hour on a completely random, alien trajectory, happening to perfectly strike a hidden piece of debris in the deep outer solar system, is practically zero. It is like firing 2 bullets from opposite sides of the Pacific Ocean in the pitch black and expecting them to collide perfectly mid-air. It is a statistical impossibility. Furthermore, the telescopic data did not show a secondary dust cloud from an impactor. There was no signature of a crash. The light curve, the graph tracking the brightness of the event, did not look like a collision. It looked like an internal detonation. The energy did not come from the outside. It came from the inside. Something buried deep within the core of 3I Atlas woke up in the freezing dark. Something triggered a release of pressure so intense that the structural integrity of the alien ice completely failed. This breaks the fundamental law of the campfire. This means that our intuition about dead rocks in the outer solar system is terrifyingly incomplete. We are suddenly forced to confront the fact that an object drifting through the coldest, deadest regions of space can harbor violent, explosive, unexplainable energy. This object is not from our neighborhood. It was forged in the gravitational chaos of an unknown star system billions of years ago. It has spent agonizing eons drifting through the interstellar medium, the crushing radioactive emptiness between the stars. We assumed it was just a rock, We assumed the rules of our solar system applied to it. But the universe is vast, indifferent, and it is hiding things in the dark that we are entirely unequipped to understand. If you seek the truth in the dark, subscribe and join us on this journey. Because when scientists ruled out a collision, they were left staring at a telemetry readout that defied the laws of thermodynamics. They were forced to look at the very chemical makeup of this shattered ghost. And what they found hiding in the spectral data was even more unsettling than the explosion itself. When we look up at the night sky, we are heavily deceived by our own biology. Our human eyes are wired to see light, not the absence of it. We look at the brilliant white dot of Jupiter or the glowing crescent of the moon, and we subconsciously assume that space is a bright, illuminated theater. Nothing could be further from the truth. Space is an ocean of absolute, suffocating darkness, and the objects moving through it are like silent, unlit submarines painted completely black. To understand the sheer, terrifying scale of what astronomers are trying to do right now with 3i Atlas, you have to understand how we actually see things in the deep void. We do not take photographs, not in the way you take a picture with your phone. When an object is hundreds of millions of miles away, moving past the outer gas giants, the sun is nothing more than a distant, cold spotlight. The amount of light that travels all the way from our sun hits the dark, dusty surface of this alien rock and bounces all the way back to Earth is incredibly, unimaginably small. It is like trying to spot a single grain of gray sand lying on a black asphalt road. From a helicopter hovering 10 miles up in the air, using only a dying flashlight to capture this fading ghost, scientists are relying on the most complex machines ever built by human hands. Instruments like the James Webb Space Telescope and the Hubble Space Telescope. These are not just magnifying glasses. They are massive, ultra-sensitive light buckets, floating in the frozen vacuum of Earth's orbit. Their giant golden mirrors are designed to stare into the pitch black of the universe for hours, sometimes days at a time, keeping perfectly still, waiting to catch a stray photon, a single particle of light. They collect these faint, dying photons drop by drop, like a man trying to catch rain in a bucket during a severe drought. Slowly, agonizingly, they build an image pixel by pixel. And because of the vastness of the solar system, there is a delay, a lag in the very fabric of reality. Light is fast. It is the fastest thing in the universe, traveling at 186,000 miles per second. But the distances out there are so immense that even light takes time to cross the abyss. When the James Webb Space Telescope captured the explosive death of 3i Atlas, it was not watching a live event. The telemetry trickling into the control rooms was already old. The explosion had happened nearly an hour before. For 60 minutes, the light from that violent detonation rippled silently across the void of the solar system, washing over the frozen moons of Jupiter, racing past the asteroid belt, entirely unnoticed by the universe, until it finally crashed into the golden mirrors of our telescopes. The astronomers staring at their monitors in the dead of night were watching a ghost. They were watching an event that had already faded into history, unfolding in high definition, and the data that poured onto those screens was staggering. To grasp the magnitude of the mystery, we have to look at the numbers. We have to look at the brutal mathematics of the explosion itself. Before the event, 3i Atlas was estimated to be roughly half a mile across, a solid, mountain-sized chunk of alien ice and dust, forged in a star system we will never see, drifting through the Milky Way for perhaps 4 billion years. It was moving at a velocity of over 50,000 miles per hour relative to our Sun. At that speed, you could cross the entire continental United States in a matter of minutes. You could fly from New York to London before you could even finish a cup of coffee. It is a speed so extreme that human intuition simply cannot process it. Yet, in the unfathomable emptiness of the outer solar system, an object moving at 50,000 miles per hour appears to be crawling. The backdrop of space is just so large that even the fastest bullets look like they are floating in slow motion. When the explosion occurred, this mountain-sized object did not just crack into two neat pieces. It suffered a total, catastrophic structural failure. The energy required to instantly shatter a half-mile-wide block of deep frozen, rock-hard interstellar ice is catastrophic. We are talking about millions of tons of solid mass held together by its own gravity and billions of years of freezing pressure, instantly overcome by a violent outward force. Imagine taking a solid mountain of granite, packing the entire core with military-grade explosives, and detonating it all at once. That is the kind of kinetic yield we are looking at in the raw data. But there were no explosives. There was no spark. There was no heat. So how did we figure out what went wrong? How do astronomers solve a crime scene that is hundreds of millions of miles away and moving faster than a rifle bullet? They use a technique called spectroscopy. And this is where the mystery of 3I Atlas morphs from a physical anomaly into a terrifying existential puzzle. Spectroscopy is the science of reading the hidden language of light. When light passes through a gas or bounces off a solid object, the chemical elements inside that object absorb specific colors. It is like an invisible fingerprint. By taking the light captured by the telescopes and running it through a prism, scientists can stretch the light out into a rainbow. When they look closely at that rainbow, they see dark lines missing from the spectrum. These dark lines act exactly like a grocery store barcode. Every single chemical element in the universe, hydrogen, oxygen, carbon, iron, has a unique, unchangeable barcode. If you read the barcode of the light bouncing off a distant object, you know exactly, with 100% certainty, what that object is made of. When comets from our own solar system explode or vent gas, their barcodes are very familiar. They are boring. They show massive amounts of plain water ice, a little bit of carbon dioxide, some ammonia, and basic organic dust. It is the standard recipe for a local snowball, but when the telescopes analyze the blinding flash of light from the destruction of 3I Atlas, the barcode was wrong. It was deeply, fundamentally wrong. The spectral signature did not look like anything born in our sun's neighborhood. The light filtering through the expanding cloud of shattered debris revealed massive, violent spikes of highly volatile, alien chemistry. The dominant signature was not water. It was carbon monoxide. In the freezing depths of space, carbon monoxide acts very differently than it does here on Earth. Out there, it is a volatile ice. It is a material that wants to turn into a gas at much, much lower temperatures than water. It is incredibly unstable. But finding carbon monoxide on a comet is not entirely impossible. We have seen it before. The terrifying part was not just what the telescopes found, but how it was behaving. The barcode revealed that this highly volatile carbon monoxide had not been slowly leaking out of the object. It had been trapped. For billions of years, deep inside the dark core of this interstellar wanderer, Massive pockets of this explosive, pressurized gas had been locked inside a prison of solid, frozen water and rock. Imagine a glass bottle entirely filled with highly pressurized, agitated soda. Now imagine freezing that bottle solid. As long as the ice holds, the pressure is contained. The bottle remains quiet. But the tension inside is astronomical. 3I Atlas was a cosmic pressure cooker, perfectly sealed by the cold of the interstellar void. When it plunged into our solar system and grazed the heat of our sun, the outer layers of the object warmed up. The heat slowly, agonizingly worked its way down through the crust. But it did not melt the ice fast enough to release the pressure. Instead, the heat simply agitated the carbon monoxide trapped deep inside the core. By the time the object flew past the Earth and started heading back out into the freezing darkness of the Jupiter orbit, the damage was already done. The thermal shock had been planted like a delayed fuse, deep inside the dead, silent rock. The pressure of the alien gas finally exceeded the structural strength of the ice. The object literally blew itself apart from the inside out. At least, that is the theory. That is the desperate, logical model the astronomers built in the first 48 hours to explain the explosion. The delayed thermal stress theory. It is a neat, terrifying, but ultimately understandable explanation. It keeps the laws of physics intact. It means the universe is chaotic, but not entirely broken. But science is a brutal, unforgiving process. You cannot just build a theory. You have to run the math. You have to prove that the mass of the gas, multiplied by the heat of the sun, equals the violent yield of the explosion. And when the computers at the major observatories crunched the numbers, the mathematical model collapsed. The math simply did not work. The thermal stress theory relies on a very specific chain of events. It requires a specific amount of heat to penetrate exactly deep enough into the core to agitate the exact amount of gas required to shatter the crust. But 3I Atlas was spinning. It was tumbling wildly through space as it flew past the sun. Because it was tumbling, the heat was distributed evenly across its entire surface. It never had a chance to focus on one single weak spot. Furthermore, the object was simply moving too fast. It did not spend enough time near the sun to absorb the colossal amount of thermal energy required to penetrate half a mile of solid interstellar rock. The heat of our star was too weak, and the exposure time was too short. Even if the core was packed full of volatile carbon monoxide, the sun could not have triggered it. The internal pressure alone was not enough to overcome the massive gravitational binding energy of the rock itself. The delayed fuse theory was dead. The shattered pieces of the object were now expanding into a massive glowing cloud of debris, a phenomenon astronomers call a coma. This ghostly cloud of shattered rock and alien gas was growing at a terrifying rate. Within a few days of the explosion, the debris field was larger than the entire planet Jupiter. A massive, expanding bubble of dust, reflecting the weak light of the sun, plunging deeper into the abyss. And this is where the true scale of the mystery begins to set in. Because the object was not just breaking apart, it was changing. When a standard rock or comet explodes in a vacuum, the pieces fly outward in all directions equally. The center of mass, the ghostly middle of the debris cloud, continues moving on the exact same mathematical trajectory it was on before the blast. The law of conservation of momentum demands this. An internal explosion cannot change the overall path of the system. If you throw a hand grenade through the air and it explodes mid-flight, the scattered pieces of metal will still collectively move along the exact same arc you threw it on. But when astronomers tracked the expanding, Jupiter-sized cloud of 3I Atlas, they noticed something entirely impossible. The center of the debris field was drifting. It was no longer following the hyperbolic curve predicted by the laws of gravity. The entire massive cloud of shattered interstellar material was actively veering off course. Worse than that, it was accelerating. The shattered ghost was picking up speed. It was moving faster away from us than the gravitational pull of the sun should allow. There was no solar wind strong enough in the outer solar system to push a debris field of that mass. There were no hidden planets in that region to pull it with gravity. There was absolutely zero external force acting upon it, yet the telemetry was crystal clear. The data did not lie. Something inside that explosion, something hidden in the blinding flash of light and the massive surge of volatile gases, had acted as an engine. The violent detonation was not a random accident of thermal stress. The sudden catastrophic release of energy had generated a directed, immense force, a force powerful enough to actively push millions of tons of shattered rock off its gravitational path and accelerate it faster into the dark. The scientific community was no longer looking at a dead rock that randomly broke apart in the cold. They were staring at a set of numbers that suggested a directed release of energy, a physical anomaly that shattered our understanding of celestial mechanics, playing out in real time on the edge of the human horizon. And as the debris cloud moved further and further away, crossing the threshold of our most powerful telescopes, the signal began to fade. The golden mirrors of the James Webb Space Telescope were struggling to catch the dying photons. The window to solve the impossible was rapidly slamming shut, and the final stream of data falling onto the screens was about to force astrophysicists to consider a terrifying, reality-breaking concept. When an object fundamentally violates the laws of physics, the scientific community does not panic out loud. They do not scream. Instead, they fall into a terrifying, obsessive silence. They lock themselves in windowless rooms. They pull up the raw, unfiltered data strings from the telescopes, and they run the math over and over again. They look for a mistake, a decimal point out of place, a glitch in the golden mirrors of the James Webb Space Telescope. Because finding an error in the machine is vastly preferable to finding an error in the architecture of reality. But as the days turned into weeks, the data from the shattered remains of 3I Atlas refused to change. The math was flawless. The machine was right. It was the universe that was wrong. The expanding, Jupiter-sized cloud of debris was actively accelerating away from the sun. It was generating its own thrust. To understand the absolute, unyielding wall that astrophysicists hit when they saw this, we have to look at a rule written by Sir Isaac Newton over 300 years ago. It is the bedrock of all modern spaceflight. The third law of motion. For every action, there is an equal and opposite reaction. This is not a suggestion. It is a cosmic absolute. If you are floating in the dead center of an empty room in zero gravity, and you throw a heavy bowling ball away from your chest, the force of that throw will push your body backward in the exact opposite direction. This is how rockets work. A spacecraft does not push against the vacuum of space because there is nothing to push against. Instead, it burns fuel, creating a violent, high-pressure explosion of gas. It channels that gas out of a nozzle at the back of the ship. As the heavy gas shoots backward, the ship is pushed forward. It is a perfect mathematical exchange of momentum. Comets actually do this all the time. It is a well-documented phenomenon known as non-gravitational acceleration. When a normal local comet gets close to the heat of the sun, the ice on its surface begins to boil off into a gas. If this venting happens unevenly, if a geyser of gas violently erupts from a single crater on the side of the rock, it acts exactly like a thruster. The escaping gas pushes against the rock, subtly altering its trajectory, steering it off its purely gravitational path. So, when astronomers first saw the shattered debris of 3I Atlas accelerating, this was the immediate, logical life raft they clung to. The rocket effect. They theorized that the explosion was not just a destructive event, but a massive, chaotic venting of gas. They assumed that deep inside the expanding cloud of dust, large fragments of the shattered core were violently outgassing, acting like uncontrolled thrusters, pushing the center of mass faster into the void. It was a brilliant, comforting theory. It used existing physics to explain an impossible observation. But then, the computers finished modeling the trajectory, and the life raft sank. For the rocket effect to push a debris field of that monumental size, the outgassing would have to be incredibly powerful, perfectly sustained, and completely directional. Think about trying to move a massive, heavy wooden boat floating on a still lake using only a pressurized fire hose. If you stand at the back of the boat and fire the water in one straight, continuous line behind you, the boat will move forward. But 3I Atlas was not a solid boat anymore. It had been blown to pieces. It was a tumbling, chaotic, violently expanding cloud of millions of shattered fragments. If those fragments were venting gas, they would be venting it in every possible direction at random. Some pieces would push forward, some would push backward, some would spin out of control. In a chaotic system like a shattered rock, all of those random thrusters should mathematically cancel each other out. The overall center of the cloud should remain perfectly anchored to its original, predictable path. You cannot fly a rocket that has been blown into a million pieces. The engine is gone. The structure is gone. To make the debris field accelerate as a single, cohesive unit, the outgassing would have to be perfectly synchronized across millions of separate, tumbling rocks, all firing in the exact same direction, away from the sun. That is not physics. That is magic. Or worse, it implies design. And scientists despise both of those answers. So, the astronomers threw the rocket effect in the trash, and they desperately moved to the next theory. A concept so strange and delicate that it almost feels like science fiction. Yet, it is entirely real. Solar radiation pressure. Most of us think of light as something entirely weightless. We turn on a flashlight, and a beam of illumination cuts through the dark. We do not feel the light physically pushing against our hands. But light is made of photons, and while a photon does not have mass in the traditional sense, it does possess momentum. When a photon travels millions of miles from the sun and slams into a solid object, it physically strikes it. It imparts a microscopic, almost infinitesimally small push. Down here on Earth, our thick atmosphere and heavy gravity completely hide this effect. But in the frictionless, zero-gravity vacuum of deep space, the gentle push of sunlight can actually move mountains. If you have an object that is incredibly light and has a massive, flat surface area, like a giant mirror, the endless bombardment of photons will act like a steady wind catching a sail. Over the course of months and years, this microscopic push adds up, slowly accelerating the object to incredible speeds. We call them solar sails. and human engineers are actively building them right now to explore the cosmos. When astrophysicists looked at the accelerating debris cloud of 3I Atlas, they wondered if they were witnessing a natural solar sail. The theory proposed that the explosion pulverized the object into a cloud of dust so incredibly fine, so impossibly thin, that it acted like a giant parachute catching the dying light of the sun. The sheer surface area of the expanding dust cloud was capturing enough photons to physically push the entire mass faster into the dark. It was an elegant, beautiful solution. But once again, science is a brutal dictator, and the numbers simply refuse to cooperate. You have to remember where this event took place. This was not happening near the Earth. This explosion happened far out in the deep freeze, past the orbit of Jupiter. At that staggering distance, the light from the sun is incredibly weak. The wind of photons is practically non-existent. It is like trying to sail a massive, heavy galleon across the ocean using the weak breeze from a small desk fan. For the weak, dying sunlight of the outer solar system to physically push a massive cloud of rock and ice at the acceleration rates we were seeing, the material itself would have to defy logic. The math dictated that the dust particles would have to be lighter than any naturally occurring rock we have ever seen. They would have to be microscopic, hollow, and perfectly reflective. To make the solar sail theory work, 3I Atlas could not have been a solid mountain of ice. It would have had to be made of something resembling an alien aerogel, a structure composed of 99% empty space, a massive, tumbling sponge of metallic, ultra-reflective gossamer. If it was a naturally occurring rock, the light simply was not strong enough to push it. If it was light enough to be pushed, then it was not a rock at all. This paradox created a massive rift in the astronomical community. The major scientific institutions were caught in a theoretical deadlock. Every time they introduced a natural, comforting explanation, the brutal mathematics of the telemetry tore it apart. They were staring at an object that possessed the violent, explosive energy of a pressurized bomb, yet somehow also possessed the delicate, impossibly light structure of a solar sail. These two physical traits cannot exist in the same object. It is like finding an object that is simultaneously as heavy as a lead vault and as light as a helium balloon. It is a fundamental contradiction of material science. The frustration bleeding out of the observatories was palpable. The telescopes were pushed to their absolute limits, staring into the dark, trying to pull one last, definitive piece of evidence from the fading ghost. And then, a small team of researchers, a group of theoretical physicists who specialize in the extreme fringe mechanics of the universe, proposed a third option. An idea so unsettling, so fundamentally alien to our solar system, that many conservative astronomers outright refused to entertain it at first. They proposed that 3I Atlas was never a comet. It was never an asteroid. It was a fragment of the primordial dark, a relic forged in a region of the galaxy so cold and so utterly devoid of energy that the chemistry itself becomes exotic. They introduced the molecular hydrogen iceberg theory. To understand the terror of this concept, you have to understand the element of hydrogen. Hydrogen is the most abundant element in the universe. It is the fuel that powers the stars. It is the foundation of all reality. But it is a gas. It is the lightest, most volatile substance in existence. Here on Earth, you cannot freeze hydrogen into a solid rock. Even in the deepest, coldest laboratories, it requires immense, crushing pressure and temperatures plunging almost completely to absolute zero. to force hydrogen atoms to lock together into a solid state. In the vast majority of the galaxy, solid hydrogen simply cannot exist. The ambient radiation from distant stars, the cosmic rays shooting through the void, is more than enough heat to instantly vaporize it. But there are dark places in the Milky Way. There are massive, lightless structures called giant molecular clouds, immense oceans of dust and gas, light years across, where stars have not yet been born. Deep within the core of these dark nebulae, isolated from all radiation, the temperature drops to a terrifying extreme. It drops to a fraction of a degree above absolute zero, the coldest temperature mathematically possible in the universe, where the very movement of atoms grinds to a halt. Theorists proposed that in these abyssal depths, hydrogen gas could slowly, agonizingly stick together over billions of years, forming massive, solid icebergs of pure, frozen rocket fuel. If one of these hydrogen icebergs was violently ejected from its dark nursery, perhaps by the gravitational shockwave of a nearby supernova, it would begin a billion-year journey across the galaxy. As long as it stayed in the interstellar medium, the deep, freezing void between the stars, it would remain a solid, silent rock. But if it ever wandered too close to a star, if it ever entered a solar system like ours, the results would be apocalyptic. Solid hydrogen does not just melt when it gets warm. It sublimates with a terrifying, violent intensity. The moment the heat of a star touches its surface, the solid structure flashes directly into a massive, invisible wave of gas. And this is where the puzzle pieces of 3I Atlas click together with an audible, chilling snap. When the James Webb Space Telescope looked at the explosion, it read the barcode of the light. It found massive amounts of carbon monoxide, but it could not find the engine. It could not find the substance that was physically pushing the massive debris field. But hydrogen gas, pure, unbound molecular hydrogen, is notoriously difficult to see in the visible and infrared spectrums. It does not reflect light well. It is essentially invisible to our standard visual instruments. If 3I Atlas was a massive iceberg of solid hydrogen sprinkled with a layer of carbon monoxide dust, it perfectly explains the impossible paradox. As the object flew past our sun, the sheer heat began to violently vaporize the solid hydrogen. But because hydrogen ice is so fragile, so incredibly volatile, the heat did not just burn the surface. It caused a catastrophic structural failure. The object blew itself apart, and as the millions of shattered fragments tumbled into the dark, they continued to fiercely outgas invisible hydrogen. A massive, silent, unseen rocket engine firing across the entire expanding debris field, pushing it faster and faster away from the sun. It perfectly answers the acceleration. It perfectly answers the missing thermal engine. It perfectly answers the strange, unexplainable barcode. But the reason astronomers are terrified of this answer, the reason they stare at the telemetry with a sense of existential dread, is because of what a hydrogen iceberg implies about our reality. If 3I Atlas is a chunk of solid hydrogen, it means our mathematical models of how the galaxy formed are deeply, fundamentally broken. It means that the dark spaces between the stars are not empty. They are populated by an uncountable swarm of invisible, highly explosive cosmic bombs, drifting silently through the void. It means that the interstellar medium is a minefield, filled with exotic, reality-bending chemistry that we have never been able to observe. Because the moment they touch the warmth of a star, they destroy themselves. We sit around our cosmic campfire, believing we understand the deep dark, believing that our laws of physics govern the entire ocean. But the telemetry fading from our screens tells a different story. The shattered ghost accelerating away from us is a violent reminder that our knowledge is confined to the light. The universe is playing by a set of rules we are not allowed to see. And as the expanding cloud of 3I Atlas finally crosses the threshold of our vision, slipping beyond the reach of human technology forever, it leaves behind a question that cannot be answered. A paradox that forces us to realize that the fundamental architecture of the cosmos is far more dangerous, far more unpredictable, far more dangerous, far more unpredictable than we ever dared to imagine. If the molecular hydrogen iceberg theory is correct, and right now, the agonizing math suggests it is the only answer that fits, then the destruction of 3I Atlas is not just a fascinating astronomical anomaly. It is a terrifying wake-up call. It forces us to confront a deeply uncomfortable truth about our place in the galaxy. We have spent the last few centuries mapping our solar system, tracking the local asteroids, and building a false sense of security. We thought we understood the neighborhood. We thought we knew where all the hazards were buried. But this shattered ghost proves that we are completely blind to the deep ocean. Imagine you are standing on the deck of a ship in the middle of the Pacific Ocean at midnight. You have a small flashlight. You shine it out over the railing, and you can see the water rippling a few feet away. Because your flashlight only illuminates a tiny, pathetic circle of water, your brain tricks you into believing that the entire ocean is empty. You do not see the massive, silent predators swimming just below the surface. You do not see the crushing depths, the hidden currents, or the rogue waves building thousands of miles away in the dark. For the entire history of human astronomy, we have been standing on the deck of the Earth, shining our tiny flashlight into the void. We only saw comets and asteroids because they were made of heavy, normal materials that reflect light. We only saw the things that wanted to be seen. But hydrogen, pure, deep, frozen molecular hydrogen, is the ultimate cosmic camouflage. It absorbs the ambient background radiation. It is practically invisible to our instruments until it is violently destroyed. And this is where the sheer mathematics of probability turn this discovery into a nightmare. Space is unfathomably, mind-numbingly huge. The distance between our sun and the very next closest star, Proxima Centauri, is over 24 trillion miles. That is a gulf of emptiness so vast that it would take our fastest human spacecraft tens of thousands of years just to cross it. Now, consider the statistical reality of 3I Atlas. We have only had telescopes powerful enough to track these fast-moving, dark objects for a few decades. In the grand timeline of the universe, our modern period of observation is less than a blink of an eye. Yet, in that tiny fraction of a second, we just happened to catch a massive, invisible hydrogen bomb flying through our exact solar system. In statistics, if you blindly reach into a massive, dark bag and pull out a rare coin on your very first try, it usually means the bag is not full of ordinary rocks. It means the bag is entirely filled with rare coins. If we found one hydrogen iceberg wandering through our tiny, illuminated campfire so easily, it means it is not alone. It implies that the dark, freezing void between the stars is not empty space at all. It is a crowded, chaotic highway. The interstellar medium must be absolutely saturated with trillions upon trillions of these invisible, highly explosive objects. An endless swarm of deep frozen shrapnel, silently drifting through the Milky Way galaxy, entirely unchecked. And suddenly, our safe, predictable solar system feels very fragile. Our sun provides us with a protective bubble called the heliosphere. The sun constantly blows out a powerful wind of magnetic energy that acts like a massive shield, pushing away cosmic rays and thin interstellar dust. It keeps the worst of the deep, dark away from our planets. But the heliosphere cannot stop a mountain, cannot stop a half-mile wide block of solid, deep frozen rocket fuel moving at 50,000 miles per hour. These objects are heavy enough to punch straight through our solar shield without even slowing down. They are completely immune to our defenses. What happens if one of these invisible wanderers does not just fly past Jupiter? What happens if its random billion-year trajectory puts it on a direct collision course with a rocky planet that has a thick atmosphere? Like Earth? The scenario is fundamentally different from a standard asteroid strike. When a normal rock hits a planet, it is a kinetic event. A heavy boulder slams into the dirt, transfers all of its speed into the ground, and digs a massive crater. It is brutal, it is devastating, but it is just a rock hitting another rock. But a molecular hydrogen iceberg is entirely different. It is a chemical nightmare. If an object like 3I Atlas entered the Earth's atmosphere, it would never hit the ground. The sheer friction of hitting our air at 50,000 miles per hour would act like a cosmic blowtorch. Remember, solid hydrogen is the most volatile, unstable substance imaginable. The moment the intense heat of atmospheric entry touched its surface, the entire half-mile wide mountain would instantly, violently sublimate. It would flash from a solid ice into an expanding wave of pure, highly combustible gas in a fraction of a second. It would not dig a crater. It would detonate in the upper atmosphere. The resulting explosion would not be a mere impact. It would be an airburst of unimaginable power. A thermal shock wave so intense it would rival the total nuclear arsenal of humanity, unleashed miles above our heads. It would incinerate the sky, stripping away the ozone layer and bathing the surface below in blinding heat and radiation. We have seen hints of this before. We have seen mysterious, unexplained air bursts in our own history, like the Tunguska event in the early 1900s, where a massive explosion flattened hundreds of square miles of forest in Siberia, yet left absolutely no crater and no solid meteorite fragments behind. For decades, scientists debated what could explode with such ferocity but leave no physical evidence. Now, staring at the shattered, fading telemetry of 3I Atlas, some astrophysicists are wondering if Tunguska was a grazing shot, a tiny, microscopic fragment of a hydrogen iceberg that accidentally clipped our atmosphere, a warning shot from the deep dark. And this grim realization extends far beyond our own survival on Earth. It fundamentally poisons our greatest dream as a species. For a century, we have looked up at the stars and imagined a future where humanity leaves the solar system. We dream of building massive colony ships, powered by fusion engines, accelerating to incredible speeds to cross the ocean of space and find new homes in distant star systems. All of our models for interstellar travel rely on a single, crucial assumption: that the space between the stars is empty. When you are designing a spaceship to travel at 10% the speed of light, which is over 67 million miles per hour, the smallest obstacle becomes a death sentence. At those mind-numbing speeds, hitting a rock the size of a golf ball would hit your ship with the force of a military bomb. To survive the journey, human engineers planned to put thick armored shields on the front of our ships to deflect the tiny, microscopic dust particles we thought were out there. But how do you armor a ship against a mountain you cannot see? If the galaxy is truly filled with a vast, invisible swarm of molecular hydrogen icebergs, then interstellar travel just hit a terrifying, perhaps insurmountable, physical barrier. The deep ocean is not a smooth, empty highway. It is a high-speed minefield in the pitch black. Any spaceship traveling fast enough to reach another star would eventually, statistically, plow directly into one of these silent bombs. It forces us to ask a chilling question. Is this why the universe seems so quiet? Is this why we have never heard a signal from another civilization? Perhaps the great filter is not war or disease or artificial intelligence. Perhaps the universe is simply built in a way that makes traveling between the stars a physical impossibility. The dark spaces are deliberately filled with invisible barriers, keeping every civilization permanently locked inside their own tiny, illuminated bubbles until their stars burn out. The death of 3I Atlas is a harsh reminder of the sheer scale of time and the brutal indifference of the cosmos. Think about the life cycle of this shattered ghost. It was born billions of years ago, long before the Earth even had a solid crust, long before the first oceans formed, or the first single-celled organisms took a breath. It was forged in the absolute zero of a dark nebula, in silence and total darkness. It spent entire geological eras drifting through the void. It survived the death of nearby stars. It survived the violent gravitational pull of rogue planets. It crossed tens of thousands of light years of empty, freezing space, maintaining its delicate, impossible structure perfectly intact. It traveled for billions of years, just to reach us, in the very moment it finally stepped into the light. The very moment it brushed against the gentle warmth of our tiny, insignificant star, the universe tore it apart. Our sun did not do this with malice. It is just a campfire. But the laws of physics are absolute, and they do not care about the billion-year journey of a silent rock. The expanding, glowing cloud of debris that was once 3I Atlas is now millions of miles across. It is continuing its lonely journey, accelerating deeper and deeper into the dark. The carbon monoxide and the violent hydrogen gas are slowly dissipating, spreading out into the vacuum, becoming one with the interstellar medium once again. Soon, the light will become too faint, even for the James Webb Space Telescope. The golden mirrors will turn away, the telemetry will stop, the data will freeze. The object will disappear, taking its final secrets back into the abyss, and we will be left sitting around our fire, staring out into the dark, armed with a new, terrifying piece of knowledge. We are not just isolated. We are surrounded. For thousands of years, human beings have looked up at the night sky and projected our own meaning onto the stars. We drew constellations. We invented gods. We convinced ourselves that the cosmos was a grand, theatrical stage, and that we were the main characters. But the shattered ghost of 3I Atlas forces us to strip away that comforting illusion. When you realize that the vast, empty spaces of our galaxy are actually choked with invisible, violently explosive icebergs, the universe stops looking like a beautiful static painting. It starts looking like a machine, a massive grinding engine of physics and alien chemistry that operates with absolute terrifying indifference. That object did not come here to send us a message. It did not cross billions of light years of freezing, empty space to challenge our scientific models. It was simply existing. It was following the blind, unthinking laws of momentum and thermodynamics. If the Earth had been in its path, it would have wiped the surface of our planet clean in a fraction of a second. and the universe would not have blinked. This realization forces a profound shift in how we view our daily existence. We wake up every morning, we go to work. We worry about borders, economies, and the trivial conflicts of our tiny, illuminated world. We treat our planet like it is an impenetrable fortress. We act as if we are entirely separated from the mechanics of deep space. But we are not in a fortress. We are sitting in a delicate glass house, suspended in the middle of a pitch-black, high-speed firing range. The molecular hydrogen iceberg theory tells us that we are completely blind to the true nature of the dark. We have built our entire understanding of reality based only on the things that reflect light. We study the blazing stars and the rocky planets. But the overwhelming majority of the cosmos, the dark matter, the wandering rogue planets, the freezing clouds of invisible, explosive gas, operates entirely in the shadows. We are the anomaly. The warmth and light of our solar system is not the rule of the universe. It is a microscopic, temporary exception to an abyss that is fundamentally dark, freezing, and hostile to life. As the final, microscopic particles of 3I Atlas fade beyond the reach of our greatest telescopes, dissolving back into the interstellar medium from which they came, we are left to grapple with the heavy silence it leaves behind. Humanity will undoubtedly continue to build bigger lenses. We will launch new satellites. We will desperately try to map the invisible hazards lurking in the deep ocean, hoping to catch the next ghost before it gets too close to the fire. But the brutal truth is, we are just an isolated species huddled around a fading campfire. We keep throwing more wood onto the flames. We build our technology. We light up our cities. We make our little bubble as bright as we possibly can. We think that making the fire brighter makes us safer. But the light does not protect us. It only blinds us to what is already moving in the cold. And out there, just past the edge of the light, it is completely, relentlessly crowded.